Good morning. My name is Prasoon Divan. I'm going to talk about programming. When we think of programming, we think of data structures, algorithms that manipulate them. If you're good, program documentation, and if you're in trouble, seeking help. This is the traditional programming process. Today, for more and more problems, we instead throw statistics at data to get our results. The overall goal of this project is to blur the distinction between these two approaches to programming. Specifically, we want to treat all these artifacts we create around programming, both the code and natural language, treat them as data on which we throw statistics to create inferences and recommendations that help traditional programmers meet their requirements. So, what kind of help can and should we provide? Here's one approach. Given a program that's giving trouble, we generate a patch that corrects the program. This approach is easy to define. We create a concrete fix that guarantees correctness. Unfortunately, the halting problem says that we cannot implement such an approach. And it's not clear we want to always give the exact solution, especially in an educational context. Here's an alternative approach. What is inferred is not the exact patch, but an abstract hint, ideally in natural language. And this hint is to be interpreted and validated by the programmer. And what it leads to is not necessarily a correct program, but a modified program that eventually becomes correct. So if you're going to generate a natural language hint, it's useful to mine not only the exact code, but all natural language artifacts created around it, including forum interaction. For hints, we need probabilistic algorithms, and machine learning is one example of such an algorithm. So like many of the projects in this department, this one too is heavily centered around ML. So our helpful programming environment works with a machine learning model, which makes it problem independent. Given a programmer difficulty, it generates hopefully a useful recommendation. And because now the historical data has changed, given the same difficulty later, it can give a different result later. In this project, we are focusing on student programmers because we want to build a system that's actually used, and we are in a university setting. And in an assignment, all students work on the same problem, so there's more similarity in the programs that are mined, which should yield better results. So we have a nice symmetry here. We have machine learning, we have student learning, and more the system is used for student learning, the better the machine learning, which should result in better student learning. So there's the possibility of a symbiotic virtual cycle. And that's the good news. The bad news is that machine learning can fail and lead students to unfruitful paths, especially if they're novice programmers. So another research question is how to solve this problem. Our solution is to bring instructors into the picture. They're the ones who are responsible for verification of the hints generated by the automatic system. And the students are responsible mainly for interpretation of the verified hints. So we now have two kinds of humans in the ML loop. The students who are getting into trouble, and the instructors who are working with the programming environment to get them out of trouble. And this makes it exciting because we can now do two kinds of user studies on the students and the instructors. So we now have an architecture to meet our goal of creating abstract hints. And the next question is, what kind of hints should and can we generate? In the time remaining to me, I'm going to talk about some examples on which we are working. Let's take the example of the familiar factorial problem. Here is what seems like a perfectly okay question, except that there's some work that shows this question could be much better. This is an example of an active question where the student has identified the problem, but not what steps they have taken towards solving the problem. A question with such steps is called a constructive question by this paper. So the hint the programming environment provides working with the instructor is not a step towards the correct solution, but a step towards the correct question, which can also be then a step towards the correct solution. The student is now prompted to come up with a base case, which works for positive arguments but not negative ones. This question then becomes a constructive one because it shows the steps taken to answer the posed question. If the system works well, they get an acceptable answer, and all is well. Here we see the same question posed in different language, and if our environment is smart enough, it can point the poser of this question towards the duplicate post. And since the instructor is involved in validating hints, they can realize that the assignment is underspecified and clarify it. So the system allows not only the student user to adapt, but also the instructor human. Another manifestation of the same problem, this time not through a natural language post, but through execution of code. Here we see that when the factorial function is provided with a negative argument, we get a Stack Overflow error. If the system is smart, it can detect that this programmer is in difficulty and recommend the insertion of this line, which says that at the start of the factorial function, they should go and make n be the absolute value of it. If we do this, we are going a long way. What would be even better is if the recommendation simply pointed the student to the post that clarifies what to do when a negative argument is given. That would be better because now the student has to convert the natural language into code and thus perhaps learn more. And a system that allows such interaction becomes a new kind of multimodal system where it works not only on natural language but also code. This is a kind of problem we often see in classes where students have trouble coming up with even the skeleton of a solution. And the response here gives the complete algorithm. It could do so in parts incrementally. And we can create this response using purely NLP if this question has been posed and answered before in a post. Or we could use multimodal learning to look at correct solutions of submitted assignments and convert them into text to be reconverted into code by the students who are given this hint. Now, to make this all work, we need appropriate data, and we spent the last few years building a system that allows us to collect appropriate program-related data, code and its input-output, and natural language text, both Piazza posts and Zoom office hour transcripts. The factorial function was chosen not because it's expected to pose difficulties, this is a well-studied problem, but because of its familiarity. These are the two focus areas for which we believe our intended system will be particularly useful. Distributed and parallel computing, because it's inherently complex, and data science, because it's not usually carried out by non-programmers. I have one RA position available for someone anxious to do a PhD in this area, and practically speaking, an unlimited number of 991 projects. If you're interested, send me a mail and we set up an appointment, and enjoy the rest of the orientation.